Hey guys, it's the Captain here. Thanks again for tuning in to another episode of Andertons TV. Today I'm at Blackstar's HQ with my friend Ian.
Nice to see you, mate. Thanks for coming up.
No problem at all. Now, a few weeks ago, I put out a question on my Facebook page asking you guys if you'd be interested in doing some kind of myth-buster videos about common misconceptions and preconceptions about guitar amplifiers. And had a really overwhelming response on Facebook. Hundreds and hundreds of people commented, you know, with the types of questions they'd like to ask. And so I thought, I've known Ian for a long time, known the guys at Blackstar for a long time, and they've got a wealth of knowledge in all sorts of amplifiers, from Handwired at the top end to mass-produced digital at the lower end. So I thought, let's ask some questions. So there's going to be, I think, 4, maybe 5 videos in this series asking different questions. You'll get to meet 1 or 2 other people also from Blackstar in those videos. So the first question, Mr. Ian,
Yes.
is, can you unravel and demystify this basic concept of the different types of amp tech from valve? Maybe we even want to go into like hand-wired versus whatever, down, you know, through all the different types into, I guess, digital being the sort of the most modern. Yeah. So,
okay, definitely.
What is it all in?
What is it all
Demystify it for us.
Right, so it's interesting actually because, as you say, within each of the categories there's subcategories as well, isn't there? So it's quite a big subject, I suppose. So I'll try and make it as simple as possible from our point of view. So starting at the top, let's start. So valve amps. I'd say you can characterise valve amps in 2 ways. One is hand-wired, which is something like Artisan or, you know, really old high watts and stuff like that would be hand-wired. And then you've got PCB-based valve amps, which again can be completely all valve, not a transistor in sight, but they use a PCB.
Yeah.
And then there's a transition then into what has been called hybrid amps, which have some solid state and also valves. The way I've always categorised this, and this is going back not just Blackstar history, but my previous time at the other company was...
you can say it.
I can say at Marshall was... if it had a valve preamp and a valve power amp, I would still categorise it as a valve amp.
Yes.
For me.
Yes.
What I would say would be a hybrid would, in my opinion, or historically, would be if it had 1 valve in the preamp and a solid state power amp. For me, that's what hybrid was.
Yes.
That's what it's always been defined as.
So if you went
like
back
a valve
to like
state.
valve state, the old,
valve
the
state,
first, and even prior to that, some of the early Music Man amps that were the other way, where it was a solid state preamp and a valve power section.
Indeed, yeah.
But there is I'm glad you said it, because there is there are some sort of purists, aren't there, that will say, even if you have an amp that has valves in the preamp stage and valves in the power amp stage, if the gain section in the preamp has a solid state element to it, some people might call that a hybrid amp.
Yeah, which is kind of the point I'm making. So a hybrid amp is very, very, it's, you know, even from something like a JCM 900, say, has some diode clippers in it, slash 22555, an old Marshall amp that I was involved in back in the day. That had a couple of LEDs in it, I think it was. So, you know, as far back as that could have been considered as hybrid, but never was. Yeah. And then as we move forward, it's broadened as a category. So I think it is, I mean, it's somewhat contentious, but I suppose just continuing the story through. Yes. So you got all valve, then you got moving into what could be considered as hybrid, or actually valve still with something in a valve in the power amp and a valve in the preamp. And then you've got true, what I would say, true hybrid, or traditionally, where either the preamp or the power amp is just completely solid state. Yeah. And then you've got, traditionally, you would say a solid state amp, which is all op amps and all transistors, no valves at all. Yeah. And then you've got digital amps, whereby the signal path, i.e. the main signal path, goes into the digital domain in some way. Most digital amps, actually the whole of the preamp is digital, and then the power amp is usually solid state.
Oh, okay, because this is where I get confused.
Right.
when you hear things Class D,
Yeah.
is the D for digital? And when you hear like
it doesn't mean digital.
Yeah.
But it is what is called a switching power amplifier. So it's a class. You have Class A, Class AB. Class D is another category of power amp design, but it doesn't mean digital. It just happens to be used in a lot of
What
digital.
happened to Class C then? I mean, it feels like the obvious omission.
Paul will tell you all about Class C, but there is Class C.
So there is a Class C.
Yeah.
You never hear it. So, okay, so I mean, that's... And I think we'll get into the sort of the characteristics of those things, but I think that's really interesting because digital amplifiers, you're really talking about now the preamp section more than the power amp, a piece of code emulating a guitar amp sound, as opposed to the use of transistors and op amps and more, I suppose, old-fashioned technology to create a tone.
Yeah, and again, there's categories within digital amps as well. So there's the traditional modelling, say.
Yeah.
And originally that was done like a black box. So it was basically you have an input signal, you have an output signal, and in between was something that kind of replicated an amp of some description. And then people have gone into what's called sector modelling, where they do every single stage of a valve amp, say, and model it. Our approach is slightly different, where we don't necessarily model. We kind of just design good sounding amps using the principles we know from our digital experience. And then obviously there's the profiling stuff, which has become more prevalent recently as well, which is a different approach again, which is taking like a snapshot of an amplifier, maybe several snapshots, and interpolating them to get a more realistic response.
And you were saying as well that this concept of digital technology has gone from, as you say, the black box approach, where you're not trying to recreate at a component level, you're just trying to recreate an overall thing, down to recreating at a component level. Yeah. But now you're at the point where you're saying, well, even though we are recreating a component level, we're also recreating based on the fact that we know if the value of this component here changes, it will change the value of this next component in an interrelated sort of correlated way. Interactive, that's the word. Yeah. And so the digital replication of a traditional amplifier, I guess gets closer.
And you know what I mean? I think this is part of people have different philosophies. You know, I mean, we don't name models and stuff on what we do, but you know, it's equally popular. Some might argue more popular to name what we're trying to go after, a twin or a plexi or whatever. But I think something that we found really interesting on our digital journey is to say, well, we start with quite an advanced, you could say, sector model or whatever. So we go down to component level, really understand the interactions, but then we say, well, actually, what if it wasn't the clipping law of a valve? If it was a different clipping law? What can you get that smoother? Because valve amps, they have a particular character. Part of the character is just down to physics. You know, the way that, I've probably said this before, but the way that the electrons, when they're boiled off the cathode and they're attracted to the anode, so you basically boil electrons, they're pulled up to the anode, and you've got a grid in between controlling that. That has a certain physical law, which gives a certain clipping mechanism, right? So, you know, you've got clipping in diodes, you've got clipping in valves. Digitally, we can do the same law because it's just a mathematical law. But you can also change that to try other stuff. So that's quite interesting from a creative point of view. Trying different stuff, you know, turning things around, turning them on their head is really interesting in terms of valves. Not to say though that, you know, there aren't companies such as ours, other companies out there, who are trying to do different stuff with valves, because there's always something new to be done, you know. And valves are like any other electronic technology. You understand them, then you try and move it forward for the likes of us who want to play guitar when we get home from work.
Well, I'm kind of feeling like that was a pretty good explanation, or a very good explanation, of the different types. I'm going to delve in a little bit further, but fundamentally, we'll stay on this sort of topic for this video, I think, and that'll be it for this one. But just so I get it in my own head again, when we're in the digital domain, is there such a thing as a digital power section? Or does that technology not exist yet? You can't code something to make something louder? Is it so? Would all when you see something like ID Core, for example, or you know, any of the other I'm trying to think of amps, you know, that you would consider digital, Line 6 Spiders or whatever. Is all the digital element though still in the preamp section? Or?
And the way that it's done generally is that the power amplifier generates what you would say clean power. Let us say clean power in most of the designs I'm aware of, and certainly how we do it. Whether it's Class AB or whether it's Class D is more efficient, so you don't need the heat sinking and stuff. So it's actually cheaper, more efficient and more lightweight than a traditional Class AB transistor design. They're both basically transistor designs.
Right.
Okay, but one is more efficient than the other. The way Class D power amps, you get the advantage of more headroom, more power at the same price, but the way that they clip is really noisy because of the technology. It isn't a nice, when you overdrive them, they sound pretty
I always used to use the analogy of, you know, when you buy like a typical radio for your kitchen or a hi-fi, not, you know, and you knew that on the volume control, that once you got it above like halfway, anything after that started to sound crappy. Whereas in a valve amplifier, you didn't. So is that what you're talking about? This sort of cheaper power amp clipping nastiness?
No. So just. That's kind of something to do. So what I'm saying is that on the Class D power amps, you get more power for the same price. In Class AB, you get a cleaner, a nicer sort of breakup. But a lot of digital amps use one of two. They either use Class AB or they use Class D. But what they do is they have that clean headroom afterwards, and then what they do is they pre-voice the power amplifier to do what the valve power section would do, and that's. So they have like a cabinet or a valve power amplifier simulator. And how well that is done basically gives you, I think in terms of delivery, I like this digital product or that digital product. In terms of live delivery, it's how well the power amplifier is designed and how well this pre-voicing bit is done. Which is, the common question is, are solid state amps louder than valve amps? Well, we've done a lot of research on that. And we think, we've measured, we know technically, that it's about 2.5 times the power of a solid state amp to get a valve amp. So if you've got a 100 watt valve amp, you need 250 watts.
We're going to do a whole separate video. That I think is going to be part 3 or part 4 of this, in this kind of, you know, what's the relation between wattage and power and actual volume, and why is it that we've all heard stories of the 10 watt valve amplifier that sounds louder than the 100 watt solid state amplifier. So we'll do that as a separate video. So
do you get what I mean though about this? Both the power amps are basically analog power amps. Well, they call them digital because they're switching, but effectively they're just generating clean power. Right? And it's what you do before it, which makes it a good guitar amp on them.
Okay, that's cool. So look, this is great. I've learned something. This idea of a digital power amp is a sort of misnomer, isn't it? But
I think so.
But so I'm gonna sort of revisit again a couple of preconceptions or misconceptions that I might have. In no particular order, but if we go back to the digital thing, do you think it's fair to say that digital gets perhaps a slightly bad rep in that it seems to be mostly used when a manufacturer wants to hit a lower price point? So actually everything about the product then is kind of cheapened down. So really it's like cheaper speakers, cheaper cabinetry, sort of cheaper,
lower power.
You know, so is it kind of unfair to point the finger at the digital bit of it and going, that's why it perhaps doesn't sound as good as your...
Absolutely. I'd say absolutely 100%, mate, I think you know, part of our philosophy at Blackstar is that, you know, whether it's solid state, whether it's digital or valve or hybrid, actually it's just electronics, and you can make most things sound pretty bloody good. And the reason why, as you say, the digital stuff historically has sounded less good was A, I think a lack of understanding as we started this technology as an industry, and then B, as you say, we've been aiming it at lower price points, and at the end of the day you can put the best digital modelling in the world through a shitty power amp and speaker, and it'll sound shitty. And that's just physics, actually.
And I think, in fairness, that's probably now, if you really do step back and you look at how convincing certain, whether it's be Helix or Axe-Fx or Kemper or whatever, which are all to some degree or another using digital processing power. Those through the right power amp and the right speaker cabinet sound very convincing.
Yeah.
So that was interesting. Misnomer number one.
Yeah.
The other one, I already know the answer to this one, but I just thought I'd throw it in there because it always makes me laugh. Yeah. When an amp manufacturer, and I think it would be fair in the early days, even Blackstar probably got some criticism of this, is criticised for saying, this is a valve amplifier because it has valves in the preamp and valves in the power amp. Yeah. And then someone says, but you've also got some element of the distortion coming through your transistor. You do sit there sort of going, isn't that just what happens when you put a pedal in front of an amplifier?
Hey! Exactly.
So I think it's kind of, a valve amp is a valve amp if it's got valves in the preamp and valves in the power amp, regardless. Yeah, for me as well.
Yeah, I'll tell you what, right, so this just goes back to, we were having a conversation earlier on, weren't we, about, an old JTM, an old JTM 45. What a sound.
Yeah.
An old Plexi. What a sound. The actual sound you heard on the records was very rarely just that product.
Right.
And I spent my childhood, or teenage years trolling the music stores of Manchester, trying to find this amazing Plexi that sounded like, I'll tell you, it was probably George Lynch on a Dokken album at the time, because he had good tone for a shredder. Very good tone. And but actually, he had one Plexi that he borrowed off Aspen Pittman, and probably, it was usually a tube screamer, but other products in front of it. He would never use, really, and those guys never really used, just the amp on its own. So even when I was back in the Marshall days, the sort of sound I was trying to get was those days was sort of Jerry Cantrell, Alice in Chains type stuff. And I felt to really nail that in those days, a really good way of doing it would be to have quite a low gain valve amp, but put pedals in front of it. So that's kind of a sound that I've grown up with. Vintage, low gain amps with a really nice tube screamer or something like that in front. And then, to me, if making it all valve compromises that, then why would you do it? Do you know what I mean? So our clean sounds, all the clipping on all our products that have got a valve in it, all the clipping is from the valves. And what we do on, this is just us, but we have different ways of doing hybrid, but the way we do hybrid on the overdrive is that we pre-clip the valve stages with effectively an overdrive pedal because that's the sound we like. It's not because we're doing it on the cheap, because our amps aren't in cheap, because there's so much bloody technology to get the sound we want. They're not cheaper. But we do it because we don't want to compromise. We could go, we're going to be all valve, but I've walked around, because I'm going on a bit about Blackstar, I don't want to do that, but you still walk around trade shows and you hear really shit all valve amps. You hear really great all valve amps, you hear rubbish hybrid amps, and you hear brilliant hybrid amps. It's not the technology, it's how it's used.
Right. Well,
that's
to be
my
honest,
opinion anyway.
And when you hear a guitar player sounding really good versus another guitar player not sounding so good.
Oh, mate, that has something to do with it, yes. Just a little bit.
Just a little bit.
Yes.
Okay. This is great, and I've just really kind of got one more question, and I guess ultimately what we can do as a little sort of snippet at the end is just like a couple of chords out of a valve, or we should say valve with some hybrid element to it, whatever. And again this TVP, which is again a sort of a more analog vibey amplifier.
That's a digital amp.
Digital, but solid digital.
It's all digital.
All digital as well.
All digital.
See,
apart from it's got a Class D power amp.
Let's have a quick fiddle between the two amplifiers. We've got the 100-watt Stage Mark II, which is what we're going to refer to as an all-valve amplifier. And we've got the TVP, which is the digital preamp modelling-y type thing with the Class D
power amp section. With TVP.
Half of me just wants you to decide which one you think is which as I'm sort of playing. But anyway, here are some chords whilst Ian switches between the two. just for fun, then I'm going to guess, which is actually I've lost my decision now, but you guys guess. So okay, give me the and the other sound. Okay, I think that's TVP. Okay. Phew!
Well
but
done.
they're pretty similar.
Yeah.
They're pretty similar.
I think one's got more. The valve amp's got more of a mid push for me.
Yeah,
and the TVP is a little bit more compressed over. But
it's the compression, I think,
Yeah.
is that
Yeah.
sense, isn't it? But anyway, look.
yeah, there you go.
So we'll do that.
Even leading now.
No, because again, it's just the way this is
sold millions of them.
positioned differently to ID Core. This is, but anyway. So I did want to go right up to valve amplifiers again, and the other thing I think, where people. I'm going to talk. We're going to go into the Class A, AB, all that kind of stuff when we talk about valves. So we'll do that
Paul's
separately.
your man for that.
Okay, but what is this? Is it a myth? This like hand-wired versus PCB, and I know there are different ways you can hand wire onto a board of some sort versus mass-produce the board.
Yeah.
I would just. I think I've got my own opinions, but from someone engineering background, what draws you to hand wiring? True point to point versus PCB versus what do you see? What goes through your head?
Right. I'll tell you what. I've never answered this question in this way, but I think it's quite interesting. Is that sometimes when you're trying to solve a big problem, say like in business, like we do now, or in design, the first thing, if it's a really big issue you're trying to resolve, like design a guitar amp, it's quite a big job sometimes. Putting a constraint in actually helps you design something, right? And the constraint that hand wiring does is the amp has to be simple, because you can't really design an overly complicated multi-channel, channel switching, blah, 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 hand-wired amp, because it would just get unwieldy, impossible. Whereas with PCB, it's a lot easier to do that. So what that leads to, I think, is that the hand-wired products, certainly our hand-wired products, I think other people's, tend to be very simple in their topology. So therefore, one could argue more pure in their tone. They tend to be lower gain, they tend to be wider bandwidth, more bass, more treble, maybe more, might say organic, because they don't have as much shaping in there. So they're maybe a little bit looser on the bottom end, a little bit scratchier on the top end, but it all adds this extra character.
Yeah.
All because we've got the constraint of we can't do all this other shit.
Yeah.
And then amp designers like myself and Paul now much more than me, when we have a PCB, we can basically do anything we want.
Right.
So therefore, the product becomes, because we're trying to supply a solution to the users, becomes more complicated. Well, everybody wants a couple of cleans, a couple of overdrives, you want some reverb, you want a couple of EQs, and then the circuit becomes more complicated, and then maybe the sound becomes more processed, say. By that I mean produced, would be a better way of saying it, because it's not processed, it's produced. And I think that has a lot more to do with than, say, the inductance of the tracks, the capacitance of the tracks, because to be honest, the difference between a piece of wire and a well laid out PCB, the differences in the inductances compared to the voltages that are at play and the signal levels that are at play is very small. It's not a second order effect, it's a third, fourth, fifth, sixth order. And sorry everyone, but I'd say if I built an Artisan, especially Paul designed the PCB, because there is some audio considerations, design a PCB, but if we did a PCB version of Artisan, then it would sound very, very, very similar, if not indiscernible from a hand-wired. But we probably would never do that, because the market wants something that's very simple, and hand wire is very reliable, it's rock solid, and it's the best you can get.
Yeah, it's interesting you say that, because the two instances of, I think that the two things where I've sort of seen the hand-wired versus PCB difference laid bare was a guy that we a chap called Mark Bartell that made Tone King amplifiers. Quite a well-known sort of boutique-y American amp, and he was a PCB guy. Everything was PCB. It was all he had an engineering background. He was like, look, if we use military grade PCBs and all the tracking and everything on there, it's super robust and and it's consistent, and away we go. Anyway, for a 20th anniversary celebration, he took his best-selling amplifier and just did a hand-wired version of it. all the same components, everything.
Yeah.
And it ended up, and he went, it does sound different. How weird is that? And anyway, when he broke it down, it's to do with the fact that the components were in at different positions in the amplifier. So what was happening was that sort of interference, or whatever word you want to, that electronic interaction, just by having two components not wired together, but just in proximity, changed the performance
of it. Lots of effects like that, which is, again, I kind of point out that maybe Paul, as an experienced valve designer in Handwired and in PCB, he would take those things into consideration and minimise those effects. But that's that kind of thing definitely happened.
So it wasn't better or worse, it was just different.
That's the thing, isn't it, mate? I'll tell you what, brilliant one for me is guitar leads.
Right.
So people will spend a lot of money on guitar leads, which is fine. You know, thankfully people do, Lee? But people will spend a lot of money on guitar leads because some give a broader band response. So you might hear a bit more treble or a bit more bass because of the inductance, the capacitance of the lead, especially if it's a long lead, right? So I don't contest that there's a difference in the sound. But on one hand, people are saying, I want a mellow sound, I want a vintage sound. Well, when you had a curly colour sound, when Hendrix plugged in with his curly colour sound lead or whatever it was, or his Vox lead, into his Plexi, do you think that lead was a good lead? Do you think that was a Put a Man on the Moon lead? It wasn't. It was the crappiest lead, probably the best available at the time, or maybe not. But the part of the sound was that lead. So whether it's good or bad is, you know, listen with these. I must admit, I'm with you. Leads-wise,
I spend money on a good lead because I want it to be reliable.
Indeed.
That's all. If somebody said, this lead's got a bit more treble than that one, I would go,
yeah, mate.
Now mine's got more treble.
You're so right.
Or hang on, now mine's got more bass.
Mate,
you know, it's like, I'm not a big believer in that whole, you know, spend £100 on a lead because it sounds better. You know, it's like, just buy one that doesn't break. That's the most important thing. And this is a brilliant thing,
and hopefully we can get to the bottom of some of this stuff. For instance, speakers. There's a lot of difference between. So I think when you come on to that, you'll see there is a lot of difference.
I'm just going to bend down here. Excuse me while I go. I said to Ian, so when you're designing amps, I said, is it mostly like trial and error? And he wandered out the room and he came back with these two books, the Radio Designer's Handbook and Radio Engineering. And he said, no, it's probably, it's 80% this and 20% trial and error. So what I did was I just opened something at a random page. So here we go, look, page 521 of the Radio Designer's Handbook. Section 6, Methods of Exciting Push-Pull Amplifiers. So come on then, Ian. What is your method of exciting a push-pull amplifier?
It's a valve or solid-state phase splitter.
I don't know. I haven't read it.
It's a valve or solid-state phase splitter, depending on what products you want. But we've done all the testing that shows that under most circumstances, a solid-state, well-designed, high-voltage solid-state phase splitter driving a push-pull circuit is indiscernible in its tone than a valve one. And the reason we do it is because it's more reliable and it makes the power valves more reliable because we drive from a low impedance.
I didn't even want to know the answer to that. I just wanted to know.
I'm glad you asked me that one.
That was amazing. So there we are. Look, thank you very much. That's part one of this little mini series of videos. I hope you guys have all learned something. If you've got a question very much within this field of the topology of an amplifier, post it in the comment section below and hopefully one of the team at Blackstar will be able to give you some sort of an answer. If you've got other questions to do with what do different valves sound like and relations between wattage and volume and many, many other things, just keep watching this series because we shall be back soon for part 2 of this as yet unnamed series of videos about guitar amplifiers. Anyway, thank you so much, sir.
Cheers, mate. Thank you.
And we shall see you next time.